with stoichiometry, there are going to be a few kind of ground rules, okay? First of all, you have to start with a balanced equation. And that's going to go in this upper part of your chart here. If you are given mass, you have to change that to moles. So only moles can go in these boxes. I say only moles in the holes. Where do moles live? They live in holes. So you can only have moles in the holes. So these boxes can only have moles, at least for this unit. Okay? Huh?
You have this, but it's like not the same.
Oh, mold of mass. I just started y'all into mold of mass.
I think so.
Was this on the back side of the homework? Mm-hmm. No, I think right here. Mm-hmm. So flip to the notes that you took a couple days ago. Okay, it's right before the homework. Does that look right?
Yeah.
Yeah. Everybody good? Anybody not able to find it yet? You good? You found it? No. You good? All right. Okay, sorry about that. Okay. Where did I put my pen? There it is. Okay, so only moles in the holes. And I'm going to say that over and over and over again. Okay. Then you're going to use your ratios, and we're going to go through that again today. And then if they ask you to turn it back into mass, you're going to do that at the end. Okay. So let me take you through some of these. All right. So they've already given us our balanced equation. We're just going to write that in the box here. Okay. And if it helps you to be able to figure out like the difference between your starting and or your products and your reactants, you can make that line there below the arrow a little thicker. Sometimes that helps people out so that they know where to plus and minus from. All right. They are telling us that we are starting out with 0.04 moles of potassium. This is already in moles, so we don't need to convert it into moles. We can just go ahead and plunk it down in our chart here. You always want to make sure that you have at least 3 sig figs in this table at all times. If you don't, these tables do not work out well for you. Okay? You end up rounding too much and you're rounding off too many digits, and then you don't come up with the right answer. So make sure you keep at least 3 sig figs in this table. Now, they did not tell us how much water we had. So at this point, we're going to assume that we have an excess amount. So we are just going to write down XS as an abbreviation for excess. It works. All right. In the beginning, have we made any of this stuff? No, we haven't started out with anything. So for our products, we haven't made anything yet. So we're just going to put down zeros, just like you hadn't made any breakfast specials last week. Okay. Then we're going to create our cloud. Now this time we're only going to have one cloud because we already know that we have more of this stuff than we need. They didn't tell us how much we had, so we just make that assumption. So we're going to go up into our cloud. When we go into the cloud, what mathematical operation do we perform? Divide. So I'm going to divide 0.04 by 2. So what is that? 4 divided by 2. 2. And I need my 3 sig figs. All right, now I've got to come down out of my cloud. When I come down out of the cloud, what math procedure do I do? Multiply. So I'm going to take, for this first one, I'm going to take 0.02 times 2. That's going to be 0.0400. Now, am I using this stuff up or am I making more of this stuff? I'm using it up. So I'm going to minus here. This will end up being the same value because it's a 2 here for our coefficient. So 0.02 times 2. We're using it up to make stuff on the other side. I come over here, I'm going to be adding. This will also be a plus. What's this value going to be? Yep, 0.0200 because the coefficient isn't written here. It's assumed to be 1. So 0.02 times 1 is 0.02. And again, I want to keep my 3 sig figs. These are not significant figures at the beginning. Zeros at the beginning of a number are not significant. These zeros are. All right. Do I have any of this left over when I'm done? No. So this is a 0. How much of this do I have left over? Who knows? But we know that we have an excess amount. We just don't know how much that is. We just know we have some left over. You will eventually get to the point where you are having to calculate this value, but we're not there yet. Here, I will have plus 0.0400. I don't like that pen. I'm switching. And here I have, well, I don't need a plus sign there, though. I'm going to get rid of that. I just want 0.0200. All right, determine the moles of hydrogen. So the moles of hydrogen are right here. We have formed 0.0200 moles of hydrogen. So this is our answer right here. Easy? All right. Any questions on that one? All right. The next one, we have C3H8. We're reacting with oxygen. We're forming CO2 and water. Balance my equation. There you go. All right. Everybody got that written in? Okay. I'm going to take, it says that I have 10 moles of this. So I'm going to put 10 here. They didn't tell us how much oxygen we have. We're going to assume that we have an excess amount. We hope we do so we can breathe, right? And then we've got no carbon dioxide or water made yet. All right. What's going to be in my cloud? What value? 10. Yeah. Because 10 divided by 1, my cloud value is going to be 10.0. All right. I'm going to come down out of the cloud. I'm going to multiply. So here I'm going to multiply 10 times 1, and I'm using this up. What am I going to have here? Right here in this box. Minus 50, because we're using it up. What am I going to have here? Plus 30. And here, plus 40. Okay, so I've got 40 here remaining. I've got 30 here remaining. Here, I don't know how much I've got, but I've got some left over. And here I have 0. They wanted to know how many moles of CO2 we have. So that is 30 moles of CO2. were produced. Ray?
How did you know to put 5 as coefficient?
Here?
Yes.
Just balance my equation. That's
Oh.
chapter 9. So I had 6 oxygens here and 4 oxygens here. 6 plus 4 is 10. I needed 10 oxygens over here. All right, any other questions on that guy? All right, sulfuric acid then. Sulfuric acid is formed when sulfur dioxide reacts with oxygen and water. And we're forming sulfur dioxide. All right, 2 sulfur. Okay, that's not balanced. I'm going to have to put a 2 here then. I have to put a 2 here then. So now I've got 4 hydrogens, 2 sulfurs. Now I got to balance my oxygens. Over here I've got 8, 2, 4, 6, 8. Yep, I got to balance now. All right, so start with my balanced equation. You guys see if you can figure out how many moles of SO2 or sulfuric acid are formed and how many moles of oxygen are needed. Go. Work with the person next to you if you need to. How'd you do? Making sense?
I'm still lost.
So they told us that we had 12.5 of this, right? So I created my cloud up here. That was 12.5. Then these are all getting used up. So I have minuses here. 12.5, or no, this would be 6.25. Hold on. Bad Lippy. 6.25. Because I took 12.5 and I divided by 2. Okay. Then I come down to get my change line. So my change line is going to be 6.25 times 2. Here it's going to be times 1 times 2. And these are all minuses because these are reactants. So they're getting used up. 6.25 times 2 is going to give me this, but I'm adding it here because this is a product. So these are my final amounts at the bottom.
How do you know the amount getting added?
These are getting used up. You're using, it's kind of like making cookies, right? You're taking flour and eggs and sugar, right? And you're taking away from those to make cookies. So anything that's on the reactant side, you're taking away from because you're using that to make the products that you're getting plussed.
What are the actual, are we just not calculating the excess for now?
Right. Yep. We'll get there.
Okay.
But you just don't know how, you know that you've got some left over. You just don't know how much it is yet. Good. Okay. So flip over and see if you can find these notes. I think. What's your homework look like tonight? Let me see what the homework looks like. This is your homework for tonight. I'm sorry I talked you there. No. Okay, it doesn't look like I do any. Okay. So, yeah, we're just going to go through this one then. We'll just do the moles to mass, and that's all we're going to do probably. Okay, so we are determining the mass of sodium chloride produced when we take chlorine gas and react it with sodium. So I'm going to take sodium here. I'm going to take my chlorine here, and I'm going to make sodium chloride. All right. So we're starting with 1.25 here. We've got extra sodium laying around. We don't know how much we've got, but we're just going to assume that it's excess. And we haven't made any of this in the beginning. So now I'm going to take this up into my cloud. When I go up into my cloud, I divide. So 1.25 divided by 1 is still 1.25. If it makes it easier on you, delineate between your products and your reactants so that you know that you're subtracting from this side and you're adding to this side. Then we're going to come down out of the cloud. So we're going to take this and we're going to multiply it by 2 for here, by 1 for here, and by 2 for here. And then we go through and add and subtract. All right. So now we have moles of this, but they wanted mass. So we're going to have to take this value and we have to multiply it by the molar mass of sodium chloride off the periodic table. So I'm going to take a sodium and I'm going to take a chlorine and I'm going to add them together. That is 58.5. And I'm going to multiply that mole amount by 58.5 to get my total. So I end up with, and I need 3 sig figs for my answer, so 146 grams of NaCl, and that is my answer.
For like the quizzes tomorrow, is it okay if we still do like the chart where you go like this and then put like moles and grams or whatever?
Oh yeah, you can do dimensional analysis all day long. Yeah. Yeah, I mean, I can do it right here if you want. The 2.50 moles. This is what she's asking, if you can do dimensional analysis for this. And sure, you can do dimensional analysis. 58.5 grams equals, and it's going to be the same amount for no. Yeah, that's right. Yeah. So you'll end up with the same answer either way, because you can see here that these are multiplying across. So I was just cutting out that step if you guys were comfortable doing that. If you're not, yeah, go ahead and do the dimensional analysis. That's fine. All right, questions on this chart? You good? Okay. All right. So next one, we are starting out here. We have TiO2 plus C plus Cl2 TiCl4 CO2. I think I got it balanced now. Yep. Okay. So see if you can come up with the correct answer for this. All right. So you're good? You got your chart filled in? Did okay with that at least? All right. Now, they wanted to know how much of the chlorine gas that we're going to need. So I'm going to go back and I'm going to focus on this section here. So in order to run this reaction and use up all of this material, I'm going to need 2.5 moles of chlorine gas. Okay. So 2.5 moles, but they want grams because they said mass. So I'm going to do my dimensional analysis because Alex likes my dimensional analysis. So we're going to do that. In every 1 mole, I've got 71.0 grams of Cl2 because there's 2 chlorines there. 71 times 2.5, that's going to give me, I need 3 sig figs, so 178 grams of Cl2. Do okay on that one? All right, so that is where we're going to break for today. You have homework tonight, which is 11-2. I believe it's 2 pages.
It's like 1 on both sides.
Yeah, so two sides, okay? So you got about 10 problems there. You can start working on those. You've got about 20 minutes left with me in here right now. So you can either work on homework, you can bring me your labs to check, or you can work on quiz retakes if you needed